Students writing physics practical in WAEC 2025, move closer here. This video is for you. So I'll be using this example on the board to explain how you are going to plot your physics practical graph. I mean the graphs you are going to plot in your physics practical. We'll explain it to you using this table. Although this table is not for 2025 WAEC practical physics, it's just a random table. So now let's start.
Now look at this. What did I have here? Ruler. Here is what? Pen. And here is what? Pencil. And here is the graph book. What is missing here is just cleaner, should in case if I make a mistake. But for this, take it away. You don't need it. Meaning that you do not need the pen at all. So pen should not reflect on your graph sheet. Now let's start with the plotting. Now what are you going to do? The first thing to do is that you should rule your vertical and horizontal line. That is where the problem used to come from, because for you to rule your vertical line and your horizontal line, you need to what? You need to check the thing you want to plot. Now looking at what we are asked to plot, we are asked to plot R2 against what? Against R1. So what's our R2? The R2 is going to be the y-axis, while the R1 is going to be on the x-axis, according to what we have been told. So now look at the smallest number in R2 and then look at the smallest number in R1. Remember that the x-axis is this is the x-axis, and then the y-axis is this is the y-axis. So this stands for the y-axis, whereby this stands for the what? X-axis. Okay, so now let me rule. Basically, whenever you want to rule graph for physics practical, the best place to put your graph, before I even show you that, now look at this box. You notice how many boxes can we find it? From here to here, that is 1. From here to here is 2. From here to here is 3. From here to here is 4. From here to here 1. From here to here 2. From here to here to here, here to here, here to here. I hope you can see that box clearly. Let me shift it like this for you to see it better. So here to this place, to here to here. Each of those boxes, they are called 1 centimeter. 1 centimeter. How is it 1 centimeter? Look at this ruler. Do you see this ruler clearly? Is it clear? From here to here is 1 centimeter. If I put it on this place like this, if I measure this place, you can see that from this place to this place is what? Exactly on 1. So that is 1 centimeter. You can see clearly. Yes, this is from here to here is 1 centimeter. That is how a standard graph used to be, and that is how WAEC graph used to be right now. They used to give you the graph in what? In 1 centimeter. All right. So the best place whenever you want to rule is that you should leave the first line. This first line, leave it alone, then move to the next line. That is the best thing to do. But should in case in some times, they say once in a while, it will require you to rule, to take your margin line here, to take your maybe your y-axis here. You can call it y-axis, you can call it margin line. But the best place is that leave this first one and move to this next one. So if I should come here, let me rule this place. You can see the fourth, you can see this one, the first one, leave it and move to this second one. So if I move to this place, then let me rule. Okay. So as you can see that I've ruled that, then that's the first thing to do. Then take your next line. You can see this place now. This is your this is your x-axis rather. Leave this place, then move to this second one. At least do that first. That will make your work easier. So having this like this first, okay. Now having done this, what I used to do is that for me, I used to put something like an arrow here, then I also put arrow here. So after doing that, I used to write y-axis here. This is y-axis, and then I used to write my x-axis here. So I'll write y-axis there and also write x-axis there. Though it's not it doesn't mean anything. You may write it, you may not write it. Now let's move on. After this, the next thing for you to do, the next step for you to do is to write which type of graph are you plotting. Remember that it is what, R2 against what, R1, whereby R2 is on the x-axis, sorry, R2 is on the y-axis, R1 rather is on the x-axis. R2 is on the what, y-axis, R1 is on the x-axis. So for the R2, this is the x-axis. Let me turn the graph, sorry. So this is the R2. So I will come here and write my R2. What is the unit you are seeing there? That is what, ohms. Okay, after writing that, you come here. Let me turn the book back. You come to this place again. This is your R1. Then what is the unit as well? Ohms. All right, what are we trying to do? We are trying to label the graph. Okay, now another thing to do next is that write your scale here. Is allowed to write it here. Write scale, write it here. So while writing your scale, then your x, write x-axis. You can put this same sign, and your y-axis for this sign. Okay, so now after doing this, so the next thing to do is now that what scale did you want to use? That is where students used to find difficult when to use a particular scale. What scale did you want to use? What scale are you going to use? That is where your thinking comes from. Now look at this. Remember that you must use a scale that will cover like 3/4 of the graph. What did I mean by that? You can say that if you use a scale whereby after plotting your graph will not go beyond everything from here to here, that is wrong. 3/4 means at least out of this 4, you should take 3 portion of it. If you divide this graph into 4, equal 4. So the graph should cover 3, at least 3 out of the 4. That's the meaning of the 3/4 I'm referring to. So, but if you take a scale whereby after plotting the graph will not pass more than this place, that means you have done nonsense. Okay, so now from the table of what we are plotting, which is what, R2 against what, R1. Now look at the smallest number in R2 and then look at the biggest number in R2, meaning that I want to write something for my words, for my y-axis like that. I want to write a scale, a graduating scale for my y-axis. Now looking at that, the last number for R2 and the biggest number, I mean the lowest value and the biggest value, I'm referring to that. So the lowest value on R2 is what, 2.9. The lowest value for R2 is what, 2.9. And then the biggest value for R2 is what, 3.6. What scale can I use that will cover at least 3/4 of this my graph sheet? Is that if I should start from here by saying 2.9 here, if I should say 2.9 here, then if I should say 3.0 here, like two of these box, you know, 2 of these blocks will represent 2 centimeters like that. So 2.9 here, then 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8. That is good. Imagine where 3.6 will stop. Again, 2 is there, starting from here, 2.9, 2.9, 3, 2.9, 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, and 3.6 here. 3.6 here. You can actually say that the graph extended, the scale extended to this place. So meaning that at least it will cover 3/4 of the graph. Now you may be worried that why did I start from this place as 2.9? That why don't I put a 0 since this is the origin? Yes, actually you can start it from 2.9 because you do not need the 2.8, 2.7, 2.6. You don't need it. So it's not necessary for you to start from here with 0. You can actually start from here with what? 2.9, because so far the graph increases with the same range of what? That should be 0.1. Yeah. So far the graph increases with a scale with a range of 0.1. You are good to go. So meaning that here will be 2.9. So the next one here will be 3.0. Here will be 3.1. Here will be 3.2. Here will be 3.3. What about, okay, here will be 3.4. Here will be 3.5. Here will be 3.6, 3.7, 3.8, and so on. So now, what is the scale? Now, what scale did I use? Okay, for my y-axis, this is my y-axis. What scale did I use? The difference from here to here is what? That is 0.1. It is increasing, it is graduating with 0.1. So now for here now, I would say 2 centimeter represents 0.1 units. 0.1 unit. What's the unit? Ohms. 2 centimeter represents 0.1 ohms. Now let's go to the x-axis. Now on the x-axis too, the smallest value I have on the x-axis is what? That is 10, and the biggest value I have on the x-axis, okay, the smallest value I have is 10.7, while the biggest value I have is 18.2. Okay, so let me assume if I'm starting from here as my 10, 10, 11, 10, 11, 12, 13, 14, 15, 16, 17, 18. Can you see it work? It's work out. Because, oh, sorry, I'm going to 18 point, I need 18.2 here. I need 18.2 here. Since the lowest value I have is 10.7, and the biggest value I have is 18.2. So the best thing for my R1, so the best for me to do is take it from 10, 11 here, 12, 13, 14, 15, 16, 17, 18. So that's the best thing for me to do. So if that, you know that 18 is here, 18 ended this place, but I need 18.2, meaning that this graph is increasing by 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, 15, 15.5, 16, 16.5, 17, 17.5, 18. So if I should shift this particular line, if I shift it backward here to this first one, to this first line here, so meaning that I will have my last number here as 18.5. 18.5. Hope you get that. I will have my last number here as 18.5. Okay, well, this graph I'm using here is not really complete because it should have another extension. Yeah, it should have another extension. So but if you are doing this in your exam, what I will do now is that I am going to take it like this as 10, 11 here, 12, 13, 14, 15, 16, 17, 18. I'll stop my 18, 19 rather, because I need 18.2. So my own this thing will stop here. But the best way for you to do is that you should take this, you should make use of these other lines too. So if you are plotting this graph in your exam, what you should do is that when you are in this type of situation is that you should shift this last line, this line here, clean it, then write it on this particular first margin you are having here. But you know, I'm not using a well standard graph, the one WAEC will give you. The one WAEC will give you to be, there will be space here for you to write there will be space here for it to write, and then it is going to be more than this. Yeah, the boxes are going to be more than this if you are using the one for WAEC. So you can encounter so many challenges while you're trying to plot your graph. Just try to make sure that everything you are trying to fix into this graph is kind of wide, is not small. Like, allow the graph to cover a larger space. Allow your drawing or your sketching or your graph rather to cover a larger space of this graph sheet. That is what I'm particular about. But for this place now, if I have another line here, it would have been better. I'll just name it or just label it as 18.5, so that I'll be able to make use of my 18.2 from this particular place. But since I did not have, if I clean this last line here, if I clean this line, this R2 axis, which is the Y axis, if I clean it there and write and draw this line on this first margin here, I should draw it here, there will not be space for me to write anymore because of this type of graph I'm using. So there will not be space for me to write. But at it being this graph has a space where I'm going to write, I would have cleaned this, then rule this line here, and then number this this graph here. Okay, so now, like I said, what I'm going to do here is that I will label here as my 10.0, then label here as my 11.0, label here as my 12.0, label here as my 13.0, here as my 14.0, here as my 15.0, here as my 16.0, here as my 17.0, and here as my 18.0, and here as my 19.0. So my own graph is going to end here, so 19.0. So now the next thing for us to do is to now write the scale that I use for here. So the scale I use for my x-axis is, the scale I use is 1 centimeter, because from here to here is 1 centimeter. Yes, 1 centimeter, meaning that from here to here, 1 centimeter is representing how many units? Is representing 1 unit. The distance from here to here is how many units? 1, representing 1.0 unit. What is the unit? Ohms. So 1 centimeter representing 1 ohms. That is what I have here. So now let's go to the plotting now. Now I'm plotting it now. On the first place I have 18.2 for the x-axis, and for the y-axis is 3.6. So I'll come here on this 3.6, then take it to 18.2. Can you trace it? 3.6 and 18.2. This is exactly on 18. This is exactly on 18. Ensure not to dot it though. And this is 18. So now each of this line will now represent 18. Look at it here. 18.2, 18.4, 18.6, 18.8, and 19. So each of those lines is representing 0.2. I'm referring to the x-axis. Again, look at it again. This is 18. The first line here is 18.2. After that, the next line is 18.4. The next line is what? 18.6. The next line is 18.8, and the last one is 19. Based on what I've written here, this is 19 here. This thing is 19 here, like this, 19.0. So I've already asterisk 18.2 for the first one under 3.6. Sometimes students used to circle it. You can circle it if you wish. So the next one I'm having here is 15.7 under 3.4. You start from 3.4 first. So my 3.4 under 15.7, 3.4. This is tracing it down. 3.4. This is 15. This is 15 here. 3.4. Can you see that? So for this one is 3.2. 15.2. Next one is 15.4. 15.6. So 15.7 is in between this line and this line. So just asterisk in between that line. So that will give you your 15.7. Okay, the next one is 13.7 under 3.3. So 3.3 is here, then 13.7. This is 13.0, 13.2, 13 point, look at, you can see it here, 13, 13.2, 13.2, 13.4, 13.6, 13.7 will also be in between this place. You can circle it. Then the next one I have here is 12.2 under 3.1. So this is 3.1 here, 12.2. This is 3. This is 12 exactly. This is 12.2. That's the first line here will be 12.2. So let me asterisk it. So, and the last two but not is 2.9 under 10.7 or 10.7 under 2.9. Okay, anyone. So this is 2.9 under where 10.7. Okay, this is 10, 10.2, 10.4, 10.6, 10.6, and what 10.7 will be here, around here. Okay, so now after that, after this, what's the next thing? The next thing is now to rule. Line I want to rule now, you have to find which one goes together, and it has to be three. Like find the three best line fit. It has to be 3. So you start checking. You see, if I take this, is not really, you can see, if I should take these 3, this and this, it's not really going. You can see that it's only 2. But if I should take this, good. So this 3, 1, 2, 3 is the best. And there is one thing you should take note. Whenever you take your line, whenever you rule your line, always ensure that one is at this side and the other one is at this side. What am I trying to say is that, let me rule this first. When you're trying to find which line to rule, let me rule this. Now look at this. After ruling this now, ensure that one falls here and the other one falls at the opposite side, which is this place. So that is the best way whenever you're trying to take which 3 lines for you to join together, which 3 lines you're going to join, which is this and this and this. So ensure that one is here and the second one is here. So now we have plotted the graph. Now what are we going to do? The next thing to now do is that we should determine the slope. So how do you determine the slope? Just join any 2 lines together. What I used to do is that the best thing to do is that take this, then join it together with this one. But anyhow, you can join from here to here, to this place. You can say, so you can determine to take your slope from here to this place, or probably, but to make work easier for you, this line you're having, this thing you're having here, this graph you plotted here, take your slope from here and join it here, or probably you take it from here and join it to this particular one. That one will make your work easier. So now let me take my slope from here. This one is here, in between here. Take it here, and then let me join it with what I have here. Okay, so that is my slope. So now label this thing. Remember that is angle 90. So label this one. This one will be your, is the highest value, x2, y2. But instead of it to call it x2, y2, you're going to call it r. Okay, let me call it r. I'm trying to call it, I want to label, though it's not necessary for you to label this thing, but let me just try to r2 prime, and then r1 prime prime. It's not really necessary. You can just leave it as r2 y2, whereby here will be what, x1 y1. I mean the lower, this one is the lower value, this one is the upper value, x1 y1, or you better call it as r2 prime and then r1 prime. Maybe this one stands as r2 prime prime and then r1 prime prime. So now, for to calculate slope, you can work out your slope on this graph as well. You can work out your slope on this graph as well. So for it to now calculate slope, it's not going to be what? The slope be what? Remember that the normal thing you know for slope is what? y2 minus y1 all over what? x2 minus x1. That is what you know on how to calculate slope. But the best way to write it for physics graph is slope equals to, this guy is the y, so that's going to be what? Changing what? r2 all over changing r1. This is the r1, changing r2 all over changing r1. So which simply means that r2 2, you know, r2 2, but use it as what? r2 prime prime minus what? r2 prime all over r1 prime prime minus what? r1 prime. Not to confuse yourself about this prime of 18, this prime and this prime of 18, probably you can leave it as what? As y2 minus y1 over x2 minus x1. Don't stress yourself, or leave it as this by saying slope equals to changing r2, which is equals to y2 minus y1 all over changing r1, which is equals to what? x2 minus what? x1. So now let's write the value out. Now what is the y2? Remember that the y is here, so the y is here, so therefore what is the y2? The y, let's trace it here. This side is for y. The y2 is 3.4 minus, then the y1 is here. You can see it's traced from here to this place, that is 3.1 all over, then the x2 is from here, you trace it down, that's what? 15.7 minus the x1 is from here, you trace it down, this is what? 12.2. What is the unit? Ohms. You know, the unit is ohms all over what? All over ohms, whereby ohms cancel ohms, so the slope is unitless. So finally, if you do 0.857, so that will be 0.0857. No unit, it is unitless. So that's all. You have gotten the slope, and that's all. So if you have any question like this, now your graph is okay, is very okay, except that the extension of what I'm trying to explain here, that's the only thing I can see that is more okay. If you can extend it to this place and rule your this 19 point, taking your the scale of your x-axis as 1 centimeter representing 1.0 unit, the best thing to do is that let 2 centimeter represent 1 unit, 1 unit of ohms. So let 2 centimeter represent 1 unit, meaning that from here, if it's here is 10, here should be 11, here should be 12, here should be 13, here should be 14, here should be 15, here should be 16, here should be 17, here should be 18. But we needed 18.2. That's where the issue comes on. So if there's another line here, it can be 18.5. Is allowed. But coming the next, that line there is going to be 18 point what? It's going to be 19. It's going to be 19. So that will look more perfect. But because of this type of graph I'm working on, there will not be, if I should try to clean this place, then root this line here, then there will not be space for me to write all this graduating scale and no space for me to label this graph. So that is everything you need to know in the plotting of graph for WAEC physics practical. So please, if you find this video helpful, do well to share this video and give me a nice comment. I still remain MATHCHEM. Thank you so much for watching this video, and I wish you success in your exam. Claim this prayer by typing amen under the comment section. Bye.